Good afternoon, everyone. My name is Tom Greenaway, and I'm a developer advocate based in Sydney, Australia. Today I want to talk to you a little bit about the Google Assistant and how you as developers can use it to build apps for the platform known as Actions on Google. So firstly, what is the Google Assistant? Well, we think of it like this. The Google Assistant is a conversation. Really a conversation between users and Google, and its purpose is to help users get things done across all the contexts and devices in their lives. And at Google, we believe that the future is really AI first. So we have been investing heavily in several areas such as machine learning, speech recognition, and language understanding to make all of this possible for the Google Assistant. But what does this mean for developers? So we have multiple devices or surfaces where the Assistant can be accessed by users, like the Google Home, the Assistant for Android, and iOS. The Google Assistant can connect users to Assistant apps written by developers like yourselves, and Actions on Google is our platform for developers that lets you extend the Assistant. So a developer can implement an Assistant app, and that is what we are here going to focus on today. With Actions on Google, you are able to connect with users wherever the Google Assistant is, giving you access to new users in new markets with new voice-driven user interfaces. And we encourage you to experiment and innovate with these new conversational interfaces, because that's what's going to prepare you both from a design, a technical, and a business level to be prepared for where this new AI-first world is really heading. So what does a conversation with an Assistant app really look like? Well, here's an example of a user invoking the Google I/O 17 Assistant app that we built for users or attendees at Google I/O to be able to ask an Assistant app for information about the event. So here you can see that the user says, "Okay, Google, let's talk to Google I/O 17. And the Assistant responds saying, "Sure, I'll connect you," or "Here's Google I/O 17. And then the conversation switches from the user talking to the Google Assistant to speaking directly to the agent or the Assistant app that this developer has created, which in this case was us. And then from there, the Google I/O app takes control and is able to welcome the user, provide them with information about what this app can do, and it can then suggest a question or ask a question to the user. So the user says, well, when is the next Android talk? And then more information is provided. So really, it immediately becomes a conversation. So the agenda for today is to talk about what it takes to design an Assistant app, and all of this is really at a high level. Then what it takes to develop an Assistant app, and what mechanisms are in place to help users discover the apps that developers build. So we all know that design is super important for the desktop, web, and mobile. But if the Assistant app on the Google Home doesn't have a screen, you might be thinking it's very simple. You might think it's just text in and text out, and that's all a conversation is. So you might then think, is design really necessary? Well, yes, design is always necessary. And it's just as important on the mobile, on the web, as it is on mobile, as it is on desktop, and as it is with a voice user interface. Because the reality is that the alternative to good design is not no design. The alternative is simply bad design. Let's take a really simple example. Say you wanted to make a restaurant reservation app. And imagine the app needs to check how many people will be coming to the dinner. So the Google Assistant, well, the Assistant app running on the Google Assistant on this Google Home might ask for how many, as in how many people will be coming to the dinner. And there's so many different ways the user could respond to that. For example, 4 at 4, which I even had difficulty saying it just then, so obviously it's a confusing sentence in English. But obviously that means for 4 people at 4 o'clock. Or the user might say, well, all of us, or they might be halfway through answering and then a dog barks in the background. So all of these situations are really possible scenarios that could play out. And you need to really understand, well, how should your app handle all of these? What is the right response? And all of this is really the design of how you design your assistant app to respond and handle these situations. So the first step is really recognizing the truth that the user will respond in many ways. And then imagining all the possibilities that could occur and trying to find tools that will enable you to handle all of those. And one way of thinking of it is with a term coined by Oren Jacobs of Pullstring, which he called interactive screenwriting. You see, writing an assistant app is a little like writing a script or a play for a play or a movie, except you get to write lines 1, 3, 5, and 7, and then oddly, you have no control over lines 2, 4, 6, and 8. And so we actually need to take this sort of mix between linear narrative design, such as movies and plays, and combine it with the engagement and retention concepts that we are probably familiar with our development of apps and games, and bring them together. When we went about building the persona of the Google I/O 17 app, there were several different decisions we had to make. So, for example, we start by thinking about what does the brand represent? Well, Google I/O should probably be knowledgeable, helpful, and encouraging. Those were the attributes we thought of. And then how does that really translate to the functional design of how the assistant app is going to work? Well, knowledge we took to mean data rich, and helpful would mean rewarding, and encouraging might mean proactive. And so from there, you also need to decide on the personality of the app as well. So for Google I/O, we felt, well, when we think about the types of people that are going to Google I/O and what would users be expecting the Google I/O brand to really be in relation to them, we thought of it as sort of geeky, eager, and humorous. And so then from all of that, we were able to create a style guide and effectively sort of a sketch of the biography of our assistant app. And so this is what the Google I/O 17 app style guide looked like. So you can see that there's a bunch of different things here. There's phrases that we thought this assistant app might say, and things that it would definitely never say. So some of that's much more formal, kind of rigid structure to the language. So for example, in things like, I did not receive a response, sounds kind of rigid and not really natural. And then there are other elements like instead of saying certain things, we would always replace those with other verbs. So for example, instead of allows, we would say lets, or due to would instead be replaced with because. And the key takeaway of using a style guide and creating this kind of document is it really helps a group of people that are working on your app to be able to have a common guide to keep them really focused on creating the same personality across all of the surface of their work. And I'd like to make another point, so using this cheese grater, which is that if you don't design a personality, users will likely still find a personality inside your product. So if you look at this cheese grater, what do you see? Well, you probably see a happy face, or at least I do. But what if the mouth was upside down? The cheese grater might be appearing as much more aggressive than we would obviously want to intend. And when we look at the top apps, the top assistant apps, the ones with the most engagement and usage are also the ones that have been the most deliberate about creating a persona. Lastly, you might want to take a quick photo of this slide. This is there's a whole bunch of documentation on the website about the design and the development of creating a persona, but we also have this sort of cheat sheet you can download as a PDF that helps you think about this process in a quick way. So now I want to tell you a bit more about how you can really build for the assistant as well. There's several steps, and you don't need to necessarily complete all of these, but I'll walk you through them anyway. So to start with, you'll definitely need to create a project on the Actions on Google console. So that's where you actually say, okay, I'm going to create an app for the assistant. And then from there, you probably want to use a tool for natural language parsing, such as API.ai, which I'll show you a bit more of in a second. Because if you don't use a natural language parsing tool, then when your assistant app interacts with a user, you'll actually be completely responsible for receiving the text and then extracting meaning from the sentences. But tools like API.ai can assist you with that information extraction. And then you'll likely connect to a webhook, so some kind of server or backend, which has the logic of your particular product and your domain knowledge that you want to communicate. So if you were, for example, a ride-sharing company, you'd be connecting into the rest of your infrastructure to actually call upon rides and fulfill those requests. Next, you'll probably want to be testing in the web simulator or on an actual device, which are both really easy, and I'll show you what that looks like. And then you'll probably want to take some time to actually enhance your app for mobile phones. So, for example, because mobile phones, when they run the assistant, have access to an actual screen, that means that there's more information we can provide to those users. And in your backend, you can detect whether or not a device has has a screen for that particular surface. And you can then customize the experience. So you could add things like images or suggestion chips, which are basically little buttons that appear in the assistant feed for the user when they're interacting with the app, and allow the user to quickly answer through just tapping. So for example, if the question was basically going to be answered with yes or no, you would probably use two suggestion chips, yes and no. And then finally, we have another section of the platform called the Transactions API, which is currently in developer preview in North America, but that's another area you would look into if you needed to, say, perform things like ordering goods online, or if you were trying to support reservations for things as well. Now, this is a really good diagram for understanding the overall flow of how the conversation operates across the infrastructure or all the different pieces of infrastructure that happen behind the scenes. So the user is asking, okay, Google, talk to Google I/O 17. That goes to the Google Assistant. It performs the speech-to-text conversion. It then looks up through a bunch of different things like natural language parsing, the knowledge graph, machine learning ranking processes, and also the user's profile to locate the app that they're referring to. Then from there, because this developer, which was us, I guess in this case, are using API.ai, that then triggers the API.ai welcome event, which is basically the entry point, or the default entry point into this assistant app. From there, API.ai sends back the message to the Google Assistant, and then from there, that goes back to the user through their device, saying, welcome to Google I/O. Then the user asks a follow-up question like, when is the next assistant talk? Again, the Google Assistant performs the speech-to-text conversion, and then that is passed to API.ai for the natural language parsing, which involves really two major steps, which is intent matching and entity extraction. Then that query probably connects to some kind of webhook server. That could be Google Cloud, it could be Firebase Cloud Functions, it could be your own server, it could run any language you want, but we're pretty fond of Node.js, so we have a lot of samples and an SDK that demonstrates how to do it with Node.js. And then finally, all of that gets back to the user, and the user receives the response. So here's an example of the Actions on Google console. And this is where you can configure your Assistant app. You can add information required for it to appear in the Assistant directory, like its name, how the app is invoked, its logo, its description. And you can also deploy your app from here or test it with the simulator and monitor some of the analytics as well. And this is an example of what the API.ai backend looks like. this is actually currently just looking at a single intent, and it's, I can't read it from here. There's a few different examples here. So this is still within the Google I/O 17 app, where they're asking what sessions are available, and you can see that the piece of information throughout all of these examples of how to ask this question is highlighted in yellow. So in this case, that's the first example is what sessions on cloud are there, or the user might just immediately say the topic that they're interested in, such as just cloud on its own. And so API.ai takes all of these examples and uses them to understand the different ways a user might ask a question. So I'll just dive a bit more deeper into this for API.ai, because it's a really important element of how you would build an assistant app, and it really takes care of this incredibly difficult problem that we're trying to make easier using artificial intelligence and machine learning. And that's obviously the natural language parsing. So the two key elements I mentioned, intent matching and entity extraction, basically this is about, the intent matching is about understanding when the user says something, which intent or which function is that basically going to be mapped to in your backend. And then the second step of entity extraction is about effectively identifying the important variables in the phrase that the user has said, extracting them from the sentence, and then passing them to the matching function. So here's another example actually that's better to highlight. So the user might say, these are different ways that the user might be asking for a recipe from a recipe assistant app. So the user might say, I want a recipe that uses 1 pound of beef. Or they could say it in a different way, like get me a recipe for chicken, or just find me a recipe. So the unit weight has been identified as 1 pound, and that can be a variable that's passed to your backend. And the protein in question is beef or chicken, or any value that is contained in the protein type, which is a developer entity that the developer has custom defined. And so this will automatically extract all of these variables, and it'll even support different ways that the user might ask this question. So the user might actually just say, find me a recipe for chicken, and I'm 99% sure that API.ai's machine learning will catch that situation and understand it as well. I've tested this kind of thing myself, and it should be able to easily substitute through machine learning that get could be replaced with find because of those examples that we've given. And here's an example of defining one of these developer entities. So for protein, the user has said, well, here are a bunch of different possible answers for that value or variable, such as chicken, beef, tofu, lamb. For chicken, there are different synonyms. So chicken could be also referred to as poultry. Beef could be referred to as steak or brisket. And so what this means is by using this developer entity in our intent, even if the user said, find me recipes for steak or with steak, then that value would actually get automatically substituted for beef, because that's in the far left column. And then that's what gets passed to your developer backend. And in addition to the developer being able to define these custom entities, there's a whole bunch of system entities that are built into the platform which handle all kinds of different situations. So there's some generics, such as an email address or a URL. And then there are some other more interesting examples like date periods or time periods. So you might know that you actually need both a start date and an end date. So if you're building a travel assistant app, you might know, well, I want to allow users to say, well, I want to travel to San Francisco and I want to leave on this date and return on that date. And then using this data type, you would be able to make sure that your assistant app extracts both pieces of information. So all of this helps with API.ai's ability to match the correct information and extract the right information from the queries that the user is submitting. And you can think of something as simple as, say, the age of a user. If you were to ask that, you would probably want to use the system.age built-in type, because that would instantly count out any answers like -10 or something like that, because, well, obviously someone's age is never going to be negative. Additionally, there's an important element called prompts. So when you provide these values in your API.ai intent, you can also say that these variables are required or not. So we could say that the protein is required, and if we do that, we can then provide some prompts, which are follow-up questions that API.ai can ask the user to get that particular value. So if I said, find me a recipe, and I didn't specify a protein, then API.ai would automatically ask the user, okay, what kind of protein would you like? And then even if I just say chicken, without giving any more context to the rest of the question, just the word chicken will then be automatically taken into account with the rest of the intent that's kind of half completed already, if that makes sense. And then API.ai will progressively keep working through all of the required variables to finish this intent. Next, there's where you define the webhook of your assistant app. So this is built into API.ai. You provide the URL. The most important element of this is that it needs to be HTTPS, and that's a requirement for security purposes. You can also debug all of the messages being sent back and to with API.ai to your server. You can see the messages are sent as JSON, and the backend server responds also with JSON. Here's just a really quick example of what it looks like to use the Node.js SDK for actions on Google. So this is honestly a very simple example that demonstrates only handling one request, which is, I presume the user is asking what topics are available at Google I/O. And then the assistant app is simply responding saying the topics covered are, and then it's listing out all of the topics, and it's following up that statement with a question, which is, what do you want to learn? And because I used the method .ask on the app variable in this area, you can see on the line that's highlighted, that means that the assistant app is going to ask that question and keep listening for an immediate response. The alternative is I could have said .tell, and if I say .tell, that will trigger the assistant app to simply state this piece of information as fact and not wait for a follow-up answer from the user. Here's just a quick example of what the web simulator looks like in the actions on Google console. So obviously, if you don't have a Google Home or you don't have access to a device that has the Google Assistant, you might need to be testing at home or while you're developing. And so the web simulator will enable this. Oh, and you can also view the JSON responses directly in this system as well. You can also do something called account linking with your assistant app. And basically, this enables you to perform effectively authentication with the rest of your infrastructure. So you might already have a concept of users in your particular app or product. That's obviously a very common scenario that a developer has users and user accounts. So the requirement is that you use OAuth 2 to perform that authentication. And that authentication is done actually through the phone that paired and set up the Google Home. So there's something we call the Google Home Companion app that allows the user to log in and authenticate. And so this is useful for recognizing your user across multiple devices and surfaces. And it's important to understand this because in our policies, we don't allow users to speak passwords out loud for security reasons. So I'll just quickly touch on the discoverability of assistant apps in the Actions on Google platform and with the surfaces that the Google Assistant appears in. So there's really three different areas that users can discover apps. One is through just pure dialogue with the surface that they're interacting with. Another is through the assistant directory, which I'll show you in a second. And lastly is the ability to link directly to assistant apps. This is an example of what we call explicit triggering. So this is if the user knows the exact name of the app in question. So in this case, the user says, okay, Google, let's talk to the Google I/O 17. And obviously, Google I/O 17 is the app name, and that routes the user to the correct assistant app. You can also do something which is more like a deep link, which bypasses the welcome intent and triggers a particular intent for the user. This is still explicit triggering, but this example is that the user says, okay, Google, ask Google I/O 17 about what was announced. And this means that the action phrase, which is what was announced, will be automatically passed to the assistant app running on API.ai or on Actions on Google directly, straight after the user invokes this agent. There's also something we're working on called implicit triggering, which is more like the situation where the user might have a general question that doesn't refer to a particular assistant app by its name. So the user might say, hey Google, I want to work out, or I want to exercise. And so then we automatically surface apps that can fulfill that request or that question and suggest options to the user based on what the apps are designed to do and things like the ratings of the apps. I'll show you what the discovery in the Google Assistant directory looks like. Basically, this is similar to something like the Google Play Store, where users can browse through apps, see images, information, carousels, and categories of apps. And they access this through the Google Assistant by invoking the Google Assistant and tapping the top right button in the Google Assistant card that appears. And lastly, you can also directly link to your assistant app from anywhere. So this could be from an existing app that you have on Google Play, or it could be through social media and just a link on the web, or on your own company's website. You could link to an assistant app. So this is a great way for the virality of your app to be picked up on social media and to promote it directly on your website, and also to encourage traffic from media and press to explore your app. Lastly, I recommend taking a photo of this because it's pretty cool. We're basically running a developer challenge where you can build assistant apps on the platform, submit them through the website, and there are a bunch of prizes to be won, including a trip to Google I/O next year. Just going to wait for people to finish taking photos. And that's totally fine because the rest of this is someone just pulled out their phone. Hang on, I'll go back. Because that's the end of the presentation anyway, so I'll just hold this up for a little bit longer. Everyone get the photo? Oh, now more people are pulling out cameras. This is very awkward. Okay, I really have to finish it up. But you can come and ask me about it. I mean, it's pretty easy. It's g.co/actionschallenge. Easy. Okay. Thank you very much, and I'll be standing in the Ask the Speaker area, sort of out the back over there, so please just come up and ask me if you have any questions. Thanks.